think whenever you are ready, we are ready to go.
I still have to check this sound.
Sound? We can hear you.
Can you can hear me, but can you hear
Birds?
Can you hear the Sonoran dog chorus back there in the back? Okay.
I can hear it.
You can hear it.
Okay, you don't hear it.
I can't hear it.
You can't? But I did hear birds.
You guys hear that, Matt? Or you got a thumbs up?
Really? Can you hear it? I mean, when I get to playing some of the songs, just filling the room. So
Coming out of the speaker.
what about this one?
It's wired.
It's wired.
You guys can hear the crows and stuff in the back? All right.
Good morning, everyone, and thank you, Jen, for inviting me. It's an honor to be here, and thank you for the steering committee for thinking of me to give this. You can't hear. Yeah, I'm sorry. Is that any better?
You want it higher?
You want it higher? How's that?
Better?
Okay. Yeah. Sorry, I had surgery a couple of weeks ago, so I'm just not bringing the energy I normally do to a talk. So I'll do the best I can. My talk is focusing on the terrestrial world. And in the terrestrial world, of course, we have an incredible diversity of suns. And I study them, and I study them, I think, in ways that most people don't. I do things like climb towers in Borneo and spend the night up there, just listening. I climb glaciers. I hike across deserts. And I do it because I'm collecting massive amounts of data, like a petabyte of data like most of you here. But I don't want to give up my 19th century years as a naturalist to kind of go out in the field and listen and make those really incredible observations, but also kind of connect to it as a human being, because I think it's really important. So I've also had a rather unusual career in that I've just not really defined any boundaries. And so to kind of give you an example, I spent 17 days this past summer camping in the Gobi Desert with musicians, trying to understand how people relate to natural sounds in their cultural practices and their sense of place, and the ways in which those lead to sustainable practices of landscapes and use of the land. I've gotten a lot of funding from the National Science Foundation to develop educational materials, and I can't believe I'm standing up in front of you saying that I just completed an IMAX movie. So we've just been busy. I push my graduate students to the max. They're very extremely talented. If you want to see it, it's actually in Boston. We developed it at the Connecticut Science Center down in Hartford. And we've been partnering also with the Perkins School for the Blind. So we've been actually doing a lot of Northeast work. I've got a student on the plane right now going to Tanzania to study chimpanzees. So what I want to do is give you a high-level view of some of the things that we're doing in the terrestrial world, and it's a really broad one too. So I'm not going to get into a lot of details of science, and no equations. So what I want to do first is describe what I view as soundscape ecology. I led a paper several years ago published in Bioscience, and I was invited to the Society of Ethnomusicology a year ago to give a talk. I just kind of wondered, why do you want to hear me talk? And so I was the only one giving a PowerPoint presentation. Everyone read papers. People in the audience were saying, hey, I want to know about your taxonomy. It was like, wow, they're reading science papers in ethnography classes in the humanities. So I want to kind of describe what I consider to be soundscape ecology, and then a little bit about the mission of the center that I direct. It's a Discovery Park center. We're leading efforts to do interdisciplinary research, and then a summary of some of the research of the learning and some of the outreach activities, the Record the Earth app, which is now collecting thousands of soundscape recordings around. And then I'm going to show you the trailer for the movie to get you excited to go at least hop in the car and go down to Boston to see this thing. So a little bit of a background. I mean, I do this work because I truly care about society, but I also care about this planet. And one of the most impressionable papers for me was a series of papers that came out in Nature and Science and PNAS and ecology letters that have been refocused and refocused and refocused. But basically what we're trying to do here as ecologists is define those limits by which we should not surpass any boundary that would potentially lead to collapse of the global system or even local ecosystems. But the one that I want to point out here is just the two that we feel as though we've surpassed already, which is the integrity of the biological system in terms of its genetic and functional diversity. And so many people believe that we're kind of in a crisis. They call it the biodiversity crisis. And you know, when you kind of look at some of the statistics, it is, I mean, you have to take a big sigh of relief. It's just like, wow, how can we do this sort of thing to this planet? Because we have marvelous creatures that we share this space and these resources with. So things like more than half the amphibians are in threatened and endangered categories. And when I go down to the tropics, I'm really stunned and sometimes concerned when I don't hear my tree frog friends. You know, they should be there. Current extinction rates right now, estimates are 1,000 times background normal rates. And so some people have even labeled this as the sixth extinction. So you know, it's something that we need to focus on. And so sometimes I have a lot of friends that are doing climate change research. And I said, this is just as important, but we don't have a good voice. We don't have a way of really communicating this as well as maybe those folks in that area. So what we need are just ways in which we can monitor species diversity all around the planet, do it in a way that is cost effective. That can be long-term, continuous, autonomous. We can just set out a recorder and a sensor and collect that information, automate the process of identifying, putting things into acoustic bins that are relatively important, and then link the mechanisms. We have to understand how these mechanisms of change in landscapes, change in habitat, change in climate, change in disease vectors, and how those eventually affect the biodiversity that we observe. So we need to focus on diversity too broadly, looking at things like who's there, but really how do they function? How do they interact? And acoustics gives us both of those. And I think that's a marvelous thing because we lack those kinds of tools. We can use the acoustics to say who's there or have at least a guess at maybe some broad taxonomic group. But we can also identify the roles that signal, that piece of information. It's the third peg of the stool in ecology now. It's information, energy, and mass. So information is really critical, and the ways in which animals navigate, the ways in which they find each other, predator-prey relationships are all oftentimes through this acoustic link. So soundscape, what is it? And there are just so many different definitions of it. There's an ISO standard. I don't care too much for it, but you know, the person that really inspired me first was Murray Schafer, a Canadian musician, really thought deeply about nature and the role that listening to nature has on our inspiration to create music. what are those relationships? And so he defined it back in 1977 as a book. He had a World Soundscape Project, and that became very famous. And then it kind of died off a little bit. There's still a few folks around, Barry Truax, for example. Murray Schafer is still alive and with us, I believe. He sits up in a cabin in northern Ontario, and the only way to communicate with him is to write him a letter. The other person that inspired me was Bernie Krause. He defined a term called biophony. It was just kind of thinking about the roles of animal communication, but at a community level. And really, before that, we were kind of thinking single species. He has an undergraduate degree from Michigan in history, and then moved to California, got into music, electronic music, very famous work in electronic music, and then fell into kind of selling nature recordings as ambient sounds in background movies. And so he was taking that revenue and going out and collecting information. If you've ever listened to his recordings, and I've been to his house, I've been to, and I've visited his archive, which sadly no longer exists because of the fire last year, but it really is a marvelous testament to somebody that went out and collected information, and collected really baseline information back in the 80s and 90s. So we have some recordings, at least in digital form, that we can go back to. I then worked with a group. Bernie actually called me up out of the blue and said, we're trying to get our ideas down on paper and accepted by the scientific literature. And I said, well, actually, I've got a paper I'm working on right now. Let's work on this together. And then I've known Stu Gage for a long time, and Elmo Farina. So we sat down and had a series of workshops at the International Association of Landscape Ecology meetings, and kind of hammered out some key ideas. Most of them was kind of defining a new field of soundscape ecology, which related back to landscapes. Getting back to really Murray Schafer's whole idea that soundscapes and landscapes are kind of synonymous in a way, but they're related. And so as all of us were landscape ecologists, began thinking about underlying patterns and processes, and then before we knew it, we had a fairly well-received paper. It now is ranking at the top 300 in all ecology citations right now in the last 5 years. There have been a series of follow-up papers too, and I just want to hit these just like kind of briefly, because I do have a lot of questions to me about what is the difference between ecoacoustics and soundscape ecology. And here's just a map, and if you want to talk about it in more detail, I'm willing to do that. But for me, soundscape ecology is this broad sense of listening to all the different sounds and putting them into relationships that are both important for humans, but also important for animals. So I kind of span more than, say, Jerome Suar and Elmo Farino, getting into the social science. And as we'll kind of see here, even into the humanities. I think it's really important for us as humans, if we're going to make an impact on the world, on the global environment, we have to communicate to the rest of the 7 billion people that live here. And so this is really important for us to protect and preserve. And really the acoustic link that we have is our most powerful to communicate. In soundscape ecology, I consider things like sound production, noise, and other kinds of forms of human perception as acoustic sense of place, which we're trying to define in my lab, but also expanding into things like human health and even environmental ethics and values. So some of the things that I'll cover here briefly. Again, it's just, I might even skip through some slides if I find myself just slowing up a little bit. Again, I apologize for not bringing the energy that I normally do. I'm usually very animated as I'm standing up here in front of people. But what we do in my center is look at trying to assess biodiversity patterns in a variety of ecosystems around the world. I'm going to have a next slide here kind of describing these in a little bit more detail. And then taking that information that we just discovered last week and put it into informal STEM learning materials and curriculum materials that include things like an IMAX movie, an online kids MOOC, and summer camp program and a citizen science program. So we have ways in which we can kind of take this fresh new discovery that we've just made, and because we're just so excited about it, translate that into materials that are easy to understand for kids and for the public. I'm also very interested in this whole notion of sense of place and the way in which we connect to sounds, and this is why I go out and listen as much as possible. It's really important, and I'll cover a little bit about that here in the talk. So in terms of research, what we're trying to do is come up with some very local to global frameworks to study what I call disturbance vectors, stressor response relationships that exist in each of the major biomes, the terrestrial biomes. So habitat alteration, looking at land use change, land use patterns, land change, but also patterns such as overgrazing. So in Mongolia, for example, they really value the land. They listen to the grass to determine whether or not it's stressed out enough or whether or not it can be grazed by their livestock. They use so much the acoustic signals around them to manage the herd, to manage the land. So I'm interested in grazing and seeing whether or not they are indeed practicing sustainable approaches. We have a lot of studies looking at wildfire, noise, climate change, invasive species, and disease. But we're also doing studies in restored prairies, looking at the impacts of hurricanes on systems and the way in which they're recovering. We had a really cool study on the eclipse. We had 40 sensors in 3 countries all across North America. We shipped out sensors all over the place. I'm going to show you some of that, the results of that work, and people in sense of place studies. But the approach of our mission is really very methodical. I'm going to each of the major biomes in the world and saying, what is reference condition for that place? What should that place sound like? So I spent 2 days, once I got to Ulaanbaatar in Mongolia, hopped on a Russian van, got all the way to the eastern steppes. There were no people there. I didn't see people for days. And I wanted to record and get baseline for grasslands. And so I've done that for just about every one of the major biomes. 9 out of 11, I've got 2 more to go. While I'm at each location, I want to look at how is that biome being stressed, how is it being used, and then to set up stressor response kind of gradients from low to high using my reference as baseline, and then moving into some kind of very, very high intense, very disturbed. So every one of these studies that I have is ongoing right now, and then feeding this global kind of stressor response model where we're trying to look at biodiversity response in both species, diversity and functional diversity. So the places I've been, it's just really cool to say, you know, this is just a marvelous planet. I mean, it's just that everywhere I go, it's just like, wow, I can't believe it sounds like this. I mean, I was, you know, a year and a half ago, I was climbing some glaciers in Patagonia, and I just could not believe how quiet it was. There were no sounds of animals, but what I could hear was the rumbling of the glaciers way far away. They were talking to me. They were haunting me. So, you know, we now have 11 different sounds of glaciers, and they're all phase changes. We're relating them to every kinds of glacier change events, and so it's really been a marvelous. Looking at the estuaries just up the road here in May. So it's a compare and contrast, and again, it's kind of a large global biogeographic study, but also looking at these in terms of stressor response relationships. We do this work. Some of you have probably seen some of the sensors in the terrestrial world, but these are like bread box size sensors. Here's one here that we had in the Chiricahua National Monument, where we're looking at the recovery of the landscape from a wildfire, the second largest in Arizona history, across burn severities and then up the life zones in the Sky Island. And so we had this acoustic sensor here, stereo, and also mounted on it was a meteorological station. At each site, I want to know what it looks like, so I take a 360 photo of it, usually hide behind some place, do a remote on it. So that goes into our database. So I can query this massive database and kind of see what this place looks like. And then we use a lot of satellite remote sensing or aerial UAV sorts of. So this a lot of the work that we do kind of takes in LiDAR data and MODIS and DVI and EVI, kind of looking at the landscape condition and the structural components of that and trying to relate it back to faunal diversity in the sonic world. So here's one of the sensors. It's kind of funny. This one got munched by, you're going to listen, you can go back into the recordings and you can hear somebody going. So I hope it tasted good because it cost me about $75 to replace that microphone. But this is a second generation. They're now on the fourth generation. So what we can do is we can place these on a tree, or I've got them in grasslands, a lot of different places, climbing trees. We're getting up in the top of the canopies. They can go for about 16 days continuously, and oftentimes we do a duty cycle of say one every 10 minutes, which will stretch it out for about 90 days. And if you do one every hour, then this thing can go for about a year. So every place I've got recorders, I do a baseline also of a year. So I have an annual cycle, so I have an idea of who's there. And then things like migratory patterns, breeding patterns, pulses of different animals that are coming through. So every one of my biomes that I'm studying, I've also got a full year record. I'm kind of looking at that phenology change. So what we do is we deploy around 6 sentinels across habitats of varying degrees, and then deploy while we're there, usually 2 to up to maybe 12 weeks. We're doing studies. I was in Borneo for about 3 weeks. And then integrate these with a variety of different kinds of other satellite remote sensing technologies, especially looking at the plant community, and then doing things like, I do a lot of GIS, so I really like spatial analysis, more anxiety, just get really excited about something like that. But we're doing a lot of ARIMA modeling, trying to understand the pulses, what I call the rhythms of nature, and then eventually building the spatial temporal kind of model. And I'm going to just kind of summarize what that model looks like here in a second. We do a lot of presence and absence. What exists in the environment, and sometimes we're looking at something that's maybe very sensitive to a disturbance. So this is a tinamou. I love the tinamou. When I'm walking through Costa Rica, I love hearing it because it means the forest is okay. And I can almost set my watch to it 5:40 p.m. It starts to call. So I'm always looking for it. And we have automated routines that just kind of go through and count the number of calls and that sort of thing, and just kind of do that across different kinds of habitats. We're also trying to develop what I call keynote species, kind of taking those species that are common to each one of the taxonomic classes and coming up with an aggregate of calls for those, and then to look at those across different kinds of disturbance gradients. That's a probably most famous in this field are the soundscape or the ecoacoustics indices. We've developed a package in our lab called Sound Ecology R. Many of you probably have used it. I teach classes in it. I hold workshops, MSS-sponsored workshops. So there's now something around 25, 30 metrics looking at things like peaks and mean frequencies and entropy in a variety of different ways. But these are what I would call kind of high-level first generation metrics. The ones that I'm getting more interested in is my fascination with humanities and the fact that they do more than just paint and sing. The computational musicology world is very advanced. Matter of fact, I would say they surpass most of the engineering signal processing that I see. And they look at something that is really important. It's called timbre. And this timbre is something that relates to the signal, the acoustic envelope or the temporal envelope that relates back to the structure of the thing that produces that sound. So if you don't know what it is, maybe you can relate it back to that structure. We've only got a catalog of about 3 to 5% of all species that vocalize. So we've got to find a way to kind of relate this back to the biology, to the physics. And so I've got some students that are working on this and finding that this is really powerful. And the tools that they've developed, mostly coming out of Europe, are very, very powerful. It's like a third dimension for sound. As you just listen to some of these places, and I wish this were just screaming loud because this is the way in which it exists while you're standing there. But these are coming from cicadas that are about the size of your hand. The first time I walked through the forest, the old growth forest, which was 300 million years old, something flew in front of me. I thought it was a bird, and then I looked at it on a tree, and I thought, no, that's a cicada. And then it started pulsating, and my ears were just hurting. I mean, I just had to cover it. But what's interesting is that before I left to do this 3-month little stay in Borneo, where I was essentially by myself, it was me, a cook, and somebody that made sure that the generator was running most of the time. The students asked me, said, are you going to study the 6 o'clock cicada? And I had no idea what they were talking about. And then they described it. It's a cicada that sings for about 2 minutes at 6 o'clock. And I said, I've got to listen to it. So the first night I'm out there, and it's like, wow, there it is, 6 o'clock. But by the time I left, I discovered that there were 7 of these. I didn't know that was. So yeah, this is me actually climbing one of these towers, but the way in which they partition their acoustic space is just really marvelous, both in terms of the frequency distributions in space, but they can do this temporally, just very, very small windows. So you wake up in the morning, this was what I heard in the morning. It's extremely loud, and I started wearing earplugs. I'm glad I took some with me. Some of our other studies are looking at, I'm just absolutely fascinated by primates. These are chimpanzees. We're at one of the Jane Goodall Institute study locations in Tanzania. And we're trying to examine how chimpanzees, or actually primates in general, are responding to wildfires. Wildfire is a huge problem in this area. It's a national park, and they're oftentimes set by humans. And so they're changing the landscape drastically. And so how are chimpanzees and other primates responding to these really large disturbances? I talked a little bit about my fascination with glaciers. I need help. I mean, this is really out of my wheelhouse, but I'm really just haunted by what I heard. So when I spent 2 days hiking up this mountain, I went to this cabin in Patagonia. I mean, this was like I was living the life of Disney, I think, in this log cabin with a fireplace. And the guy who was my guide went down and then brought up a bottle of just fantastic Argentina Malbec. And then we hiked up the next day to the top of this glacier, and I put my hydrophone in and just put my earphones on, and I thought, oh my God, this is just an incredible discovery. At least some people have done this, but we have weeks and weeks and weeks of continuous data right now. We're trying to correlate it with things like meteorological information, solar radiation, temperature, but you can listen and you can infer the different kinds of at least changes, phase changes. And I think that I can hear sublimation. It's just one of those things you look at a spectrogram and you listen very carefully. But anyway, I really want to explore this even further. So some of you that have read the bioscience paper probably recognize these, but these are what I call rhythms of nature. But what we did is we developed an annual study, kind of recording 10 minutes on an hour, and then calculating the amount of diversity across the soundscape. And the first one here is just plotting out this kind of diversity in relationship to an average for the month. And this one up here is an old growth forest. The one down here is a secondary forest. This here is an old orchard, tree orchard. This one here is this is the orchard. This is the wetland, I'm sorry. But as you move down here, what we get is what I call flatlining. You're silencing the landscape as you modify and take away the different habitats. You homogenize the landscape, make it all corn and soybean, which is what I'm surrounded by out there in Purdue. You just silence it. There's nothing. And then you add pesticides and you really got something that's truly silent. You have no biological activity. is this the world that we're going to live in the future? I don't know, as we try to feed 9 billion people. The soundscape over the diurnal period is also very fascinating too. As humans, we've recognized the dawn chorus as being something that helps wake us up. It's one of those, how the day greets us. It's oftentimes very beautiful, but oftentimes we don't realize that this dusk chorus is pretty spectacular too. If you listen very carefully, you can hear the insects almost handing off to one another. It's just really fascinating how the sounds change so rapidly within sometimes even a 30-second period. But the sounds at night, I've just been amazed by. Throughout the planet, the sounds at night are far greater and far more diverse. And when you begin to look at really what exists there and what's more active, wow. So as ecologists, are we just kind of on the job, sleeping on the job? I hope not, because we've got biodiversity that we need to really focus on, which is active at night. We need to monitor it, but we also have other forms of stress on that system, which is light. So I'm just going to go through this real quickly. So if you're just going to take those two graphs that I just showed you and plot them out, some kind of summary. Here's this annual summary, what the spring sounds like, and then you have this change here. So the winter's really quiet, right? You have a few birds that are chirping, and then eventually things kind of thaw out, and you got the spring peepers screaming at you. Sometimes they're screaming now in January, which is not a good thing, I think. And then you have the birds coming in, and then you have the insects that emerge. You have a peak towards the end here where you have this cacophony of all the animals. And then it starts quieting down. And then you have this other diurnal cycle here. And then if you can begin to label these as different kinds of phases, what I call phases and transitions, and thinking about triggers, the ways in which they change, then you begin to get to where I'm going with my global program here, which is to develop this stressor response model that I have here. And it would take me about 20 minutes to kind of describe to you all these different parts and points here. But the idea is things like climate change is going to warm the environment, and it's going to shift some of the animals. It's going to reassemble. So some of the insects, which are all developed on a function of temperature, degree day temperatures, they're going to come earlier. So, as I'm looking at our records, our cicadas are coming earlier and earlier. And there's other insects that are coming earlier and earlier. So what does that mean for animals that are kind of that are all defined by photoperiod in their life histories? So the photoperiod is not going to change, but the climate is. So does that reshuffle the community and the acoustic links? The functional diversity might be impacted, right? And what does that mean to like different periods during the day, at night, and the way in which you hunt in the different phases of the crepuscular periods? So, and then if you alter the habitat, you're going to depress the number of animals that are there, and so you're going to listen to it. And so, as a reflection of the soundscape, you're going to be able to detect fewer animals there, and fewer numbers of individuals in the species. So this is where I'm going, and I'm getting close to actually being able to develop this. So everywhere I go, I've been testing this model and building it, and it's held up fairly well in just about every one of the biomes. I'm going to skip through the Costa Rica study. If you want to look at how we combined acoustic sensors and LiDAR technology, I can give you a paper on that. It was published in 2014. So as you probably encountered on the marine side, once you start collecting data like this, you find that you can't put it in Excel, you can't put it in Access. You have to build your own tools, right? And I was hoping not to get into this because I like being an ecologist, but I had to become an engineer and a computer scientist there for a while because the data were coming in so fast. We know the big data era really well. Everybody in this room is wrestling with that. The analytics side, how to actually analyze data when the traditional statistics no longer work because the assumptions are invalid. So we've done things like developed our own web-based system. So we have a software package you can download off the web and then contribute if you want through GitHub, its development that actually allows you to query our entire archive and its reduced form. So I can put the whole thing right now, something like maybe 10 million recordings I think we've got on a laptop. But it also goes and extracts out WAV files and FLAC files, processes them, and then we have an interface between this and our Sonicology R package that's called Familial R. So you can go and do PHP, extract it out, and then throw it into our package. And we've also got some Python scripts. So we're running things on a fairly large supercomputer, 4,000 nodes, I think, something like that, on a regular basis, having to process thousands, tens of thousands. But you can listen to these files. If you just hop online, you can listen to. And I find this to be marvelous. Sometimes when I get data coming back from a field expedition, I want to know, well, are the files good condition? And this is the tool I use. So here's the Sonicology R package. Those of you that are interested in using this in classes, come see me. I have some manuals that we've developed, some guides that allow you to go download some data, run some Python scripts that you can download too. So it's becoming a really hot package right now. I'm glad to. We've got some other tools. Chris, are you there? One of my former students, Chris. Maybe he can't talk back.
Yeah, I have him on.
I wanted to showcase this. So Chris is an undergraduate at URI, and he was in my lab for about 2 years. He came to me and says, Dr. Pijanowski, I'd like to kind of take this book and then write some software around it. And I thought, yeah, right, okay. And let's just try the first chapter. And before I knew it, he had the third chapter, fourth chapter. He had the whole book done, and an interface and visualization tools. And I thought, wow, this is an undergraduate. So you're getting a good student prepared by Purdue, but he's going to tackle the world here because he's got some great talents. We've also developed some tools that allow you to what I call perceptualize long-term change. So we've been doing some studies in cooperation with the Crane Trust in Nebraska, where they've been taking a photo once an hour for 7 years. So they called us up and said, hey, could you put an acoustic recorder next to our sensor? So we've been doing that for 3 years. And the idea here is that you need to kind of understand how these landscapes change, but oftentimes it's one of these things where it's extremely abstract. You have to what I call perceptualize it. By perceptualizing, you are listening and seeing at the same time. Let's see if this works. I hope it does. So what's not in here are all the other tools that we've developed. So we do an RGB coding of every pixel. You can focus in on a pixel so you can begin to look at vegetation changes going from brown to green back to brown. Looking at the amount of water, the amount of blue sky, amount of clouds. And then on this axis here, we're calculating these ADIs, ACIs for every one of these recordings. This is developed by Ben Gottesman. A lot of you know Ben, one of my PhD students. And we've just submitted a paper to Ecological Informatics on actually how we've developed this tool. It's really kind of fun, but it does give you a sense of how are things changing both visually and sonically. STEM education. So, you know, like Bernie Cross, who called me up and said, hey, we'd like to kind of join forces and find a way to kind of get our ideas in paper and get some ideas published. Another person from Boston calls me up out of the blue. Oh, I heard you on NPR Science Friday. I think your work is really cool, exotic. And have you ever thought about doing a movie? And I just kind of laughed. He says, what do you got in mind? He says, well, I don't have any money for it, but you know, let's see what we can do. And before I knew it, I was writing a National Science Foundation proposal. And I thought, oh, I just can't do this. I mean, this is to EHR. I mean, I have no idea what the lingo is. I'm a geeky scientist, and they want to know the pedagogical this and that. And so submitted it. It got ranked #1. I just fell out of it. I just went, what? You got to be kidding me. So yeah, that's what I've been doing for the last 2 years, is just running around the world, making a movie, and then getting behind the camera, which is like really cool. It's like I get to be Steven Spielberg for a couple of years. But part of the project here is to develop some other tools. So this is the kids' MOOC.
I'll be leading you on a tour of the center. First up, find the notebook.
If you were to go to our center, this is what it looks like. Same color on the wall. First place they have to go is see Dr. P, which is me. That's my office. It kind of looks like my office. I play guitar. They then go to the team, and every one of my students has to learn how to communicate with kids. So I say, build a room.
All right, we're all hitched up and we're ready to roll out for another Road Ready Campground review. Today we're coming from Mormon Island State Park in Grand Island, Nebraska, or Jonathan, Nebraska, just outside of Grand Island, Nebraska. We stopped here to visit grandparents, and this was a spot. Well, there wasn't many campgrounds here.
Yeah. And then I had another student who just got so excited about working with kids and not so terribly excited about the big supercomputers and wanted to work outdoors. And so we developed the summer camp program as part of this, which was really fun. You know, I didn't think that I would get so excited about this, but I did. And we developed it around some theories coming out of Oregon State, and we just published a couple of papers in educational journals. I never thought I'd do this, but we have. But the idea here is to kind of get kids outdoors and listening, but giving them the tools, the same tools that we use. We give them the same sensors, and they love it. They call it the magic box. And we oftentimes have them map and diagram out. So go out and listen and develop a sound map. What do you hear? All right. But we're also asking them, how do they associate it with it? Because we're getting into what's called situational interest in educational pedagogy, which is developing this initial contact with new information. How do they feel about the sounds? Do they go out and they really like the birds? What do they think about the sounds of the highway, the planes flying over? And and then tell us about those experiences. And so here is the manual, which is really spectacular. Right? Everybody in my lab put this together. They just put their heart and soul into it. And we mapped everything out to the next gen standards. Sound is, by the way, the suggested, like one of the umbrella topics that connects every one of the STEM fields. And so we have an instructor's manual that kind of describes everything in a lot of detail. Everybody can read it online. And then what I wanted was just learning about the fundamentals of physics and biology up front. And then during the middle, I want them to play games. So we did some gamification. We had sound bingo. We've got sound bingo, find your pair. I do these things with adults and they love it. And then it's the adventure part, which is find a place that scientists have gone and learned about the sounds and explore those online. So they go to Borneo, for example, and they listen to everything that I have to say about my personal experiences there, and then the research that we're doing. So that is what we call YELS, your Ecosystem Listening Labs, YELS. And this was developed here in Connecticut, actually, the Connecticut Audubon Society summer camp program at the Penn of the River. We've got a lot of theories that we've been testing and looking at different affective and cognitive outcomes and the roles they play in making an impression and interest in the topic and then interest in STEM fields in general. I'm just going to page through some of these. Truly very close here, and I hope some of you have worked with the Perkins School for the Blind, but what a marvelous group of individuals. They want to change the world the same way I do, and they think that, here's what's key. You know, as I've worked with some of their students and some of the better students, they have the best ears on the planet. It's like, help me. You can listen better than me, teach me how to listen. And they do, and they're really excited about that. And sometimes I'm just playing sounds from all around the world, and to them it's like candy. They just don't turn it off. I want to hear more. We take them out and we do sound maps. We work with them to kind of develop pins, and we have structures. We're using 3D printers to map out the different places, and they listen, and then they put pins on the basis of what they hear. So they feel for the bird, they put the bird someplace, and so they're mapping, just like those of us that are visually capable. So it's just a great place. When we developed the IMAX film, we said we're going to make sure that the visually impaired had the same cognitive experience. So all the formative and summative evaluation were done with visually impaired students too. Okay, getting down to the home stretch here. So some of the outreach that we're doing, I'm a big believer in land-grant universities. I think that we have a responsibility to take the information that we just discovered last week and get it out to the public as fast as possible. We'll do our very best to get it all peer-reviewed, making sure it's good stuff. But the outreach is very important, vital part of the mission of Purdue University. So one of our big outreach, we have a program that's very similar to CBAS, but on the terrestrial end. It's called the Global Sustainable Soundscape Network. We've had over 120 people that have gone through this program. The idea is to meet at each one of the main like biomes around the world, continuing my theme of marching through the world's ecosystems, and then to focus on some kind of a topic. You know, our first one was at Elder Leopold Camp, at the very seat that he wrote the Sound County Almanac. Was just like inspirational. And what we did is we went back into his notes from 1941, 42, I think it was, where he was just listening to the birds, and he took such meticulous notes. We reconstructed the soundscape that Eldo had heard at that time, and then we compared it to what it sounds like today. So the person that did that at University of Wisconsin was on NPR that year. In the Sonoran Desert, we were looking at wildfire, and we had one up here at the Wales History and Research Reserve hosted us. The grasslands in Nebraska, and then we got down to Costa Rica, and we had a film crew come down. I was just kind of stunned that CNN had found out that we're going to be down there, so they were doing a study or a special series on biodiversity. So they came down. So if you just type my name in CNN, you can get a 8-minute interview by me talking about the work that we're doing down there. And then the special summer that I just had last year, which was camping in the desert with musicians. I'm going to talk to you a little bit about what we're trying to do there. I'm working with communities, developing a community soundscape planning guide. So we've got a guide for Northwest Indiana. We work with Gary, Indiana, to kind of map out the cultural sounds, the natural sounds, and then the noise, and the ways in which they need to kind of think about controlling those, and the ways in which they can exploit the natural sounds for their benefit, community benefit. We have a guide that's online, and communities can go through this whole process of scoring and actually working through a bunch of policy documents. A really cool tool that we have, I hope you can download our app. It's called Record the Earth. You can go out and record your soundscape. You key in information, key in notes. This is the interface to it. And I'm just going to go back up here for a second because there's just, so you hover over and you get the keywords. You get a world diagram of everything. So what you can do, and this is just not for North America, this is global. We have over 100 countries represented, 5,200 recordings, 3,000 users right now. And the idea is you can map out all the places in the world that make people happy, and then probe, well, what's in those files? What makes, and it's really interesting because in some parts of the world it's birds, in other parts it's insects. It's like, what's that about, you know? There's a big data analytics here. I mean, I don't understand half of the multivariate statistics that were built into this by our group, engineering group, analytics group on campus. But you can query it space and time and listen. You can blog about it. You can say that you can like it. I mean, it's just way too cool. Every Earth Day, I just mounted a campaign to say, let's go out and record the Earth because I want to know what the Earth sounds like on Earth Day every year. We've been doing that since 2014. So first time we did it, I was on, I gave over 80 interviews. I was on NPR Science Friday twice, NBC Today Show, BBC World News Service, live interview with Australian National Public Radio at 3 o'clock in the morning. I'm not sure I'll do that again, but it was kind of fun. So yeah, we've gotten, I mean, this has just been hot. Many of you know that it is truly hot. So they did a story, Science did a story in News 2014. That's me in Borneo right there. I was on the cover of Science. It's really cool. Interviewed by Nara. That's my film crew. That's a film crew from CNN. I've been quoted in Nature and the New York Times magazine. So Business Week, Nova did a little special on us, and it's just been really nice to have someone. And what I've had to do is develop a means to communicate to the public and get out of this technical, journal voice that many of us are in, and find ways to inspire people. And it's been a great. So a couple of comments on this humanities connection. I've always liked the arts and I love music. I'm a classical music geek. I've always thought that science informs, art inspires, and together they can transform it. Why don't we have these partnerships often enough? And after writing a paper last week with an ethnomusicologist, I know why. It was really hard. It was truly hard. Our professional norms are vastly different. Our vocabulary is just like nuts. We don't talk the same language, believe me. But we can do this. So as part of these workshops, we do things like team building exercises. And the idea here is to empower people and to get people to think that they can contribute. I want graduate students to come and talk and be empowered to talk, but I also want to make sure that the folks from the arts and humanities and the social sciences are not kind of intimidated by those of us that are kind of geeky scientists and engineers. So we do things like build towers. This is the tower built by a couple of the local Mongolian graduate students. And we do a lot of who am I and what do I do? We put this on walls. We try to build a matrix and find ways where we can connect to one another. What are our connection points? And so we map those out and then we move them around. And then what are the problems that we study? And then how can we work together? And then how can we bunch them together in phases? So we spent 5 days at a GARE camp outside of Ulaanbaatar. Okay. And then, a lot of camping, which is really part of the team building. We've all become extremely good friends. I'm just going to skip this. If you want to see this paper on acoustic communities and how the humanities and the sciences can work together, let me know. GARE camp. having fun. You got to have fun pictures like this, right? Yeah, these are marvelous vehicles. I wouldn't recommend sitting in them for more than 10 hours a day, but I have come back very sore. But the drivers just drive like maniacs. There's us camping, and I got to meet. I mean, this guy is like, this is like John Lennon of Mongolia. He's extremely famous. I was just like graced in his presence, like wow. And he was singing. He's singing doing throat singing at the place of his birth. He was born at this very spot. So he's singing back to the spirits and thanking them for the gift of life. And it just, wow. It's a land of horses. Okay. As promised, my trailer. I wish we could have turned it up because yeah. So, been funded by the National Science Foundation, 6 out of 7 directorates so far. So on my bucket list is one more. Purdue University, DNR. I can't do this without amazing graduate students. They're truly so dedicated. Sleeping in the lab, and I come and go.
Good time for questions.
Questions?
Any questions? Yes.
Yes, I was wondering if the sensors record video
Some of them, yes. So we have the terrestrial bat recorders that we oftentimes co-locate, and they're full spectrum too. So you can set them to trigger on at a certain kind of amplitude and frequency range, and they're marvelous instruments. And the company that develops this Wildlife Acoustics right down the road here in Massachusetts, I've been out there, great group of people. I love Ian and his group. Are really listening to scientists what they need, and they're developing automated tools to recognize species, bats, and doing an extremely good job. I mean, I'm just very impressed with it.
And you have data like that on the website on the bat diversity?
Not on the bat diversity. Yeah. I was down in Patagonia in Tierra del Fuego, and I put some up, not thinking I was going to get anything.
You turn the volume down, I think.
Oh, okay. We recorded 4 species, and only 2 are known. So, yeah, I've got them going. I just, one of my students that was focusing on bats decided to go into policy instead of the techie stuff. So we had a study in Panama where we're looking at cave size and mostly soundscape diversity. kind of looking at the island theory of biogeography for caves. So she started that study. I don't think she'll ever finish it, unfortunately. But yeah, we do some. And we do pick up some insects too, and tree frogs. So there's a lot of activity there.
And they all eat each other too.
Yeah, they're all avoiding each other too. Yeah, right.
Any questions? Well, please join me in one round of applause here for Bryan. We are on a break, so please eat, drink, be merry, and talk. Thank you. Anybody who has not loaded their presentation, who will be speaking in the next group between now and lunch, can bring it up, and I can do that right here. Let me give you your power back. I don't know where my power went. Stop recording.
it's probably soon.
Let's see. Stop recording.